Hi everyone, I'm V now and I'm a developer advocate at lakeFS, the open source project that offers data versioning at scale for your data lakes. And today, as data practitioners, we expect our data pipelines to behave in a very predictable way, just the way we wanted it and coded it to be. But in reality, though, because of all the multiple moving components of the pipelines, it's often a mess. What can go wrong with the data pipelines? I mean, you name it. Could be the infrastructure upgrades, EMR Spark upgrades, or a business logic change that came in from the business. How many times did you have to update a KPI definition and rerun all of your data pipelines to backfill your data, right? And do I even need to touch upon the legacy DAC pipelines and the minute, small modular update that we needed to do on those legacy pipelines that none of us wanted to even touch? But to effectively deal with all of these changes and to push the data and the pipelines into production, how do we go about doing that? Or the only thing we probably need is to have an effective testing strategy in place, meaning we want to run the unit tests, integration tests, and even end-to-end tests because we do have multiple data sources that are being consumed by the data pipelines to do the ETL transformations and different data consumers often concurrently reading from the data that we have put up for our consumers downstream. Although we have these testing strategies in place, the most critical component of our strategy is the availability of data, the availability of production-like data to robustly test the pipelines. Some of us use mock data, create sample production data, copy them outside of our production into a sandbox environment and do all the testing that we need. But a mock data or a copy of a part of the production data is never going to mimic what the real life data is going to be. But some of us on the extreme try to copy all of the production data into a test environment or a staging environment, as you call it, to run our testing, to run our tests on the pipelines. But then in this case, though, we have to deal with duplicates of data versions sitting across in different environments. And in addition, we also risk the data privacy violations that we don't want to. Now, once we have the effective testing strategy in place, we need to understand to effectively test these data pipelines in a production-like setting, we need an efficient way to create these isolated test or development environments for our data. Just like how we do it for our applications, we need a similar environment for data. And today, I'm going to talk about how one can create these development and test environments for your data with lakeFS branching strategy. This is how we're going to implement CI/CD, which will improve the robustness of our pipelines and the reliability of the data that we serve. As we talked about, this is a very high-level data lifecycle, starting from different data sources, producing data for us, and then the complex ETL pipelines that transform the raw data into a consumable format, and often, concurrently being consumed by these different downstream applications. And now, if we want to look at how to implement CI/CD, in the software engineering world, the best practices look like these, right? Starts with the build phase, test, and the deployment phase. And we have best practices defined for each of these phases. But now, how do they translate into the data world? In the build phase, we want to have data version control, not for just one file, not for just one table, but for all of your data lake. So the entire data lake needs to be versioned. In the test phase, however, we need to have that ability to create these isolated test environments that we just talked about. Production-like test environments, while not affecting or not risking the production data, is critical to create or robustly test your pipelines. But in the deploy phase, however, in addition to testing, we want to run certain quality checks because as data practitioners, we've seen that the quality and the reliability of data has always been questioned by our downstream consumers. To ensure that is taken care, we need to run a suite of quality checks. And despite all the checks, there are still chances that things might go wrong in our production, right? So in that case, we need to have the capability to automatically roll back things as well. Now, once we have all of that taken care, let's just look into how can we efficiently version the data lake, like all of your data lake in production like setting, right? Which is exactly where lakeFS comes in. lakeFS lets you version the entire data lake, just like how Git does for source control. Say if your data has been sitting in an object store, AWS S3, Google Cloud Storage, Azure Blob, or even MinIO, for example. You can create a data repository on top of that, just like how you would create a Git repo. And then you can create multiple branches. Branches are just abstractions that let you create multiple versions of your data lakes. Like, as you can see in this example, we have a delta table, which has multiple tables, table 1 and 2, and we have these branches, main and v1, which are created to create the versions of these tables. Now, once we have lakeFS helping us do these versions, we also need to understand how our existing applications, be it Kafka, Spark, Airflow, or any other host of data applications we have, will interact with our object store. Currently, if you have any of these applications talking to your object store, you can configure them to talk to S3, for example, through lakeFS by offering the versioning benefit. And lakeFS sits on top of these object stores and lets you do that. And in terms of interruption to your current code, for example, if the current S3 path that you're using in your Airflow DAG is what is mentioned above, the only improvement or the change that you need to do is just add the name of the branch in one of the prefix and you're good to go. And with these minimal interruptions into your existing code, you will be able to run lakeFS and get the data versioning at scale as needed. And when I say lakeFS is creating these multiple branches to give you copies of production-like data, lakeFS is not exactly copying all of the data to a new branch. So when you create a new branch, what happens underneath the hood is that it only copies pointers to the underlying storage objects. And therefore, the branch creation is just a metadata only operation. Nobody is copying all of the data outside of your production. It's just the pointers. So obviously what happens is the minute you start creating new data objects in the new branch, lakeFS does copy on write to write them back to the object store as well. Now, let's just have a quick look at the demo and see how lakeFS can actually help you do that. This is how the lakeFS UI looks like, right? I'm going to create a new repository, blank repository, and I'm going to call it Netflix Movies Repo. And I want to create this repository on top of my MinIO bucket, which is going to be Netflix Movies Repo bucket, which we just created in here. Just Netflix Movies data. Let's just call this data. Oh, it's not mandatory. Let's just keep it as this. Okay, so we have a repository here, and now you can use lakeFS UI or lakeFS CLI or lakeFS offered API clients. What I'm doing here is I have a Jupyter notebook where I am installing the lakeFS Python client and using Python to talk to the lakeFS underneath to do the Git-like operations like branching, merging, committing, and even reverting, for example. So let me go back here, and as you can see, the lakeFS client is installed. I'm doing all the installations, and these are the lakeFS configuration details. And once I have even Spark configured, because I'm going to use Spark to transform the data in here, I'm going to call my repository, which is here, Netflix Movies repository. Okay, so I already showed you how to create the bucket and the repository from the UI. You can do it on either sides. You can do it from the UI as well, or you could do it from the Python client as well here, as I'm showing. What I'm going to show here is we create an ingest landing area, and then we dump some data into the ingest area, just like how our typical data environment looks like. And then we're going to copy the data from ingest to staging, do some transformations and data cleaning, and then write it to our production, which is the main, right? Let's just move with it. As you can see, once we created the repository, by default, we have a main branch, and there is no other branches. Let's go ahead and create these ingest and staging branches. And once we create those staging branches, you can see there are 3 branches here and here as well. And you can see all these pointers are the same, meaning all these branches point to the same storage objects underneath. They're all pointing to the same data. Now let's dump some data into our daily partition into our ingest area. We're just trying to simulate what a data environment looks like because we have different data sources writing to our ingest location every day. You can go to lakeFS, we can go to UI, the ingest landing area, and see for our today's partition, we have some data that's landed here. Let's move forward and let's copy the data from ingress to staging because, as you all know, that's where we do all the data cleaning and playing with it. All right, as you can see, in the staging area, under raw prefix, I am writing the same input file as well. We've just copied it from the ingest area. And once we have the data in staging, let's just do a little exploration, trying to understand what the data looks like. We've got 8,000 records just for this demo purpose, and this is what the data looks like. And let's see what the null counts in our data are, right? It has a couple of null rows for certain specific columns, and we don't want any null values, obviously. So let's just clean them up, and it is bound to have no null values because we just cleaned them up, right? So only this clean data, we want to write it back to staging and push it to our production. And to learn more about that, feel free to check out lakefs.io for detailed documentation. Also join the Slack community if you would like, to have a detailed architecture discussion of how different companies are using lakeFS. And this is just a few examples of data organizations who are using lakeFS as well. Thank you so much. Thanks for joining the call, and I hope this was useful for you.